Hi everyone, welcome to my tutorial for SIT210 Embedded System Task 3.1b. In this project, I will show you how I created a system that detects sunlight using an Arduino Nano 33 IoT and a BH1750 light sensor. Whenever the light starts or stops, the Arduino sends a signal to IFTTT and the IFTTT then sends a message notification on my phone. In this video, I will guide you step by step through the hardware setup, IFTTT configuration, the Arduino code, and a live test of the project. By the end, you will be able to recreate the same project for yourself. So let's discuss the required components for this task. For this project, the hardware is very simple. You will only need an Arduino Nano 33 IoT, which provides the Wi-Fi connectivity to our project, and a BH1750 light sensor, which measures the light intensity in lux, and a few jumper wires to connect them together. I didn't use a breadboard for this build. Instead, I directly connected the pins of the sensor to the Arduino with jumper wires. This makes it compact and easy to set up. So now, let's discuss the wiring of sensors to the Arduino. This is my hardware setup. Here you can see this is my Arduino Nano 33 IoT, and this is my BH1750 light sensor. So on this light sensor, we have we have 5 pins. So the pins on this light sensor are VCC, ground, SCL, SDA, and AWR. So we don't need the AWR. So let's check how will we connect the this remaining four. So firstly, we will connect the VCC from the sensor to the 3.3 pin on the Arduino Nano. So let's check. Okay, so this is the 3.3. After that, we will connect the ground of the sensor to the ground of the Arduino board. So let's connect the ground wire. After this, we will connect the SDA pin of the sensor to A4 on the Nano. And similarly, we will connect the SCL pin of the sensor to the A5 on the Nano. So let's connect this A4 and the SCL pin A5. So now this is fully set up, and let's move on to the setting to the setup of IFTTT. Let me keep it aside. Okay. So now we will set up the IFTTT, which is the service that will deliver the notification. First, log into your IFTTT account at ifttt.com. So for this task, we will need two applets. So let's create them. After creating two applets, we will do the first applet is for when light starts. For the if this condition, choose webhooks and use the event name sunlight start. For the then that action, choose notification and send it and set it to send a message to your mobile. The second applet is for when light stops. Again, choose the webhook for the trigger and this time use the event name sunlight stopped for the action. Also select notification. With these two applets, we will get alerts both when sunlight begins and when it ends. Once the applets are ready, we need the webhook key. Go to the webhook service page on IFTTT and click on My Applets. Choose any one of them and scroll down. You will see a link, a URL. So copy the key that appears here and we will paste it into our Arduino code so the Arduino can separately communicate with IFTTT. Now, let's move on to the software side. Open the Arduino IDE. Before Before writing code, make sure you have these libraries installed in your Arduino IDE. Wi-Fi Nina for Wi-Fi communication, Arduino HTTP client for sending requests, and BH1750 for reading the light sensor. In the code, enter your Wi-Fi network name and password and paste the webhook key you copied from IFTTT. So let's just discuss how the logic of this code works. So the Arduino reads the light intensity from the BH1750 in lux. It compares the lux value with a threshold value, which I set to 300 lux for this project. If the light is above the threshold, The Arduino triggers the sunlight started event. If the light falls below the threshold value, it triggers sunlight stop event. Each event is sent to IFTTT through a secure HTTPS request. The request also includes some extra data such as the total sunlight time and current lux level. After uploading the code to the Arduino, open the serial monitor. You should see the lux reading being displayed in real time. When I shine a bright light on the sensor, the lux value rises above the threshold. The Arduino detects sunlight, prints sunlight detected on the serial monitor, and sends the sunlight started event to IFTTT within seconds. I receive a notification on my phone now. When I cover the sensor, the light value drops below the threshold. The Arduino triggers sunlight stopped event, and I receive another notification on my phone. The serial monitor also shows the response code from IFTTT. A status code of 200 means that the event was sent successfully. So I repeated this process several times by covering and uncovering the sensor. Each time the notification matched the change in light. The system responded quickly and worked reliably without any false trigger. This confirms that the hardware, the code, and the IFTTT setup are all working together correctly. And that brings us to the end of this tutorial for SIT210 Embedded System Task 3.1b. We built a simple but effective IoT system using the Arduino Nano 33 IoT and BH1750 light sensor. We connected the hardware with jumper wires, set up two applets in IFTTT, added the webhook key into the Arduino code, and tested them successfully. The result is a project that can detect when sunlight starts or stops and instantly notify the user on their phone. Thanks for watching. I hope this tutorial helped you in building your own sunlight detection project. Thank you.